My friend and one of his friends are going to start a gaming YouTube channel. His friend is going to be doing all the editing, so he has to send him the gameplay video he captures. One of his videos, which is an hour of Fallout 4 gameplay, is over 15 gigabytes. So I'm making this tutorial partially for him so he can learn how to compress videos into reasonable file sizes, but I'm also going to cover a lot of closely related topics like how to record or stream with optimal performance. This video will give you an understanding of FFmpeg, x264, and the h264 codec. h264 is used in pretty much every video-related site, software, or device you encounter. It makes possible everything from YouTube to Twitch to GoPros. If you're a creator, streamer, or anyone else who deals with video on a regular basis, I think you'll find this tutorial very useful. So before we go into actual compression techniques, I'd like to get some lingo out of the way. FFmpeg is a program that can do a wide range of operations on a whole bunch of different video and audio types. Most recording software, video editors, and compression apps use FFmpeg under the hood. You can also use FFmpeg directly in a command prompt or terminal, but I'm not going to cover that in this video. H264 is a standard for encoding video that all major software adheres to. You can imagine it sort of like a language. Since we both know English, we can exchange ideas. If we both have software that understands H264, we can exchange videos. X264, not to be confused with H264 though it is related, is a plugin for FFmpeg that allows it to encode H264 video. It isn't the only way to create H264 videos, but it's very common and it's the technique I'm going to be covering today. It's installed by default pretty much anywhere you might need to use it, so the information in this video will be applicable to a wide range of software. And finally, containers. You almost never encounter .h264 files. Usually videos are MP4 or MOV. MP4 and MOV are both container types that support H264. The container doesn't have any actual content. It just holds the video and audio streams and some metadata about the file. Now I'm going to explain some techniques that are used to get videos down to a reasonable size. Probably the most important one is lossy compression. Lossy compression is the idea of discarding data to reduce the file size. H264 is great at figuring out what data isn't that important, so we can drastically reduce the file size without much loss in quality. This image is using JPEG, but it's the same idea as H264. You can see that as the file size decreases, the image looks about the same. It always amazes me how well this works. And when the file starts to get really small, you can see the detail that's being removed, and it starts to look really bad. But in real life, files almost never get compressed this extremely. This next compression technique doesn't apply to images. Most videos aren't just a random string of unrelated pictures. Usually each frame is similar to the last, but maybe some things have moved or the point of view has changed. So we can use that information to compress the video even more. Take for example this video of just panning across that image. We could encode each frame as a separate image, but that would be terribly wasteful. So X264 can identify when something in the last frame is still visible. It doesn't encode the entire image on each frame, it just encodes how much the old part moved and this small new section on the side. This offers huge data savings, and it's not just limited to motion. H264 can handle videos rotating, zooming, tilting, and even stretching and warping with incredible accuracy. One important thing to note is that the amount of action in the video majorly affects how big it will be. For example, if we have a video that's just a still frame, it can basically just be encoded as an image with a specified length. But if we have, say, a gaming video, lots of new data needs to be encoded on every frame. So when you're encoding video, there are three things that you have to worry about: performance, file size, and quality. And in most cases, when one gets better, the others get worse. You can control how X264 encodes using two parameters: preset and your choice of CRF or bitrate. The preset determines how much processing power will be used to encode your video. Faster values use less power but tend to result in larger file sizes for the same video quality. Slow presets are the opposite. They take more time but usually compress more efficiently. In practice, the efficiency of the compression varies wildly based on what you're encoding, and often slower presets are actually less efficient. I'll go into more detail on this after I tell you about CRF and bitrate. CRF stands for constant rate factor. It determines how good the video will look, and it goes from 0 to 51. 0 is lossless, which means ginormous file sizes, and 51 just looks like trash. Setting CRF will use the amount of data required to make the video look that good or bad, so the file size will depend on the preset. An increase of 6 CRF will roughly double the file size, and a decrease of 6 will halve it. Bitrate is sort of the inverse of that. It specifies the amount of data per second in the video stream, and thus the file size. The quality of the video will depend on the preset. For 1080p video on the internet, the bitrate is usually about 2,000 to 6,000 kilobytes per second. It also varies a lot based on the application. For example, GoPro videos directly off the camera can be almost 30,000 kilobytes per second. Okay, so what combination should you choose? First of all, there's almost no situation where you would want to use the slowest preset, placebo. It can be 3 to 5 times slower than very slow, which as the name suggests is very slow, and there's almost no perceptible increase in quality. So with that in mind, I did a bit of testing and made this chart of preset versus file size for a few different CRF values. The higher CRF values made drastically smaller files, but I adjusted the scales so all the lines look about the same. Notice how they all have a dip on the very fast preset, and on some of them the slower presets are actually worse. The test video I used for that chart was only 10 seconds long, so I also ran through the presets on an 11-minute video of me playing Minecraft with some friends. The results are similar. File size sharply decreases down to very fast, then goes up a bit, and is about the same as very fast at slow. So if you want to compress a video file down to a smaller size overnight or something, slow to very slow would probably be good based on how fast your computer is. If you're recording or streaming game, very fast is probably your best bet unless your computer isn't very strong or if you're streaming something that uses a lot of CPU. For example, when I would stream music production on my laptop before I upgraded to my tower, I would use ultra fast. Music production doesn't have that much action or fast motion, so I could live with the lower efficiency, but I needed as much CPU power as possible directed at the music rather than encoding the stream. The best preset really depends on what you're doing and what CPU you have, but I would suggest almost never using faster, fast, medium, or placebo. Whether you should use bitrate or CRF depends on if you're streaming or recording to a hard drive or SSD. If you're streaming, you'll want to test your internet upload speed using a site like speedtest.net. Then set your bitrate to like 2/3 to 3/4 of your upload speed. My upload speed is just under 6 megabytes per second, so when I stream, I usually set my bitrate to about 4,000 kilobytes per second, which is 4 megabytes per second. This leaves room for other stuff or people who might access the internet and ensures the stream won't lock up. You probably shouldn't use CRF for streaming because it makes it hard to tell if you're going to exceed your upload speed. For recording, I would recommend between 14 and 24 CRF, depending on how much you care about file size or video quality. Keep in mind that lower CRF values take more processing power to encode. I prefer to use CRF for recording because I can change the preset and not have to worry about the video quality changing. So now, let's go through a few examples. First of all, my friend's Fallout 4 video. I'm going to re-encode it using a program called Handbrake. It's free, open source, and compatible with all 3 major OSs. You can get it at handbrake.fr. I'm going to set the CRF to like 15 because we want it to look good and it's okay if it's a few gigabytes. This is a 60 FPS video, so I'm going to make sure to set the frame rate. This setting has to do with what devices the video will be compatible with. It makes almost no difference to the file size or speed, so I usually just put it on auto. And finally, we will set the preset to very slow because we have plenty of time to let this run. After re-encoding, the file is only 5.5 gigabytes, and we could probably get it much smaller with minimal quality loss. Next, I'll show you how I would set up a stream. The software I use for streaming is OBS, which stands for Open Broadcasting Software. It's also free, open source, and cross-platform, and its website is obsproject.com. For bitrate, I use the average bitrate setting. It allows the bitrate to go higher during complex sections of the video and lower during parts without much going on. As I said before, I set the bitrate to about 4,000 kilobytes per second. For preset, I use very fast instead of ultra fast because my computer is quite a lot stronger now. Even so, this song is pretty demanding, so I don't want to go any slower. Finally, I'll record some Minecraft. Since this isn't a stream, I'm going to use CRF. I'll put it on 14 because space isn't much of an issue. Minecraft is not at all demanding, so I'm going to put the preset on slow. Before you do an important recording or stream, I would recommend doing a test and then watching it to make sure it went smoothly. If I had done that with this video, I would have seen that I needed to increase the CRF or choose a faster preset because it can't quite encode in real time. I thought I was okay because the CPU usage was at like 80%, but if any core gets maxed out, it will stutter, even though the average usage looks fine. And that's it. I hope you learned some stuff from this video. Now you can go make some other videos.